On this episode of Inside Engineering, we talk with Maia Tatinclaux and DJ Wacker about anaerobic digesters, positive power systems, and is wastewater better than drinking water? Inside Engineering, untold stories and fascinating people from the world of civil engineering. This is episode 15. Wastewater with Maia Tatinclaux and DJ Wacker. Inside Engineering is an RK&K podcast. Learn more at rkk.com/podcast. And welcome back to another episode of Inside Engineering. We've got a couple of great guests with us today. To my left is DJ Wacker. DJ, thanks for joining us.
Thank you, Zim.
Yep. And all the way on the end, we have Maia Tatinclaux. You are welcome also to you. Thanks for being here.
Thanks, Tim.
I tried to jump into the next section before I welcomed you. That's you both are in our wastewater group. And you've already said some things before we started recording this morning about how much you love wastewater. So we're going to get into that. But first, why don't you each go through and tell us what it is that you do here at RK&K. DJ?
Yeah, so I guess as a wastewater engineer, we basically help our clients with anything related to wastewater treatment. As our group likes to put it kind of inside the fence. So once the wastewater gets to a treatment plant, we do studies, we do designs, we help with construction of upgrading, designing new features, new facilities inside a wastewater treatment plant. So what Maya and I do on a day-to-day basis is very similar. We communicate with our clients, we find out their problems, we relay them back to our team, and then figure out a way to actually solve those problems. So that's kind of the simplest way to put it without getting into any of the technical and dirty details of wastewater.
Sure. No pun intended. Right.
No.
All right, Maya, what can you add to that and or extend into some other facet of what you all do or something that you especially enjoy doing?
Yeah, so as DJ said, it's all from the planning stages of wastewater treatment and improvements all the way through construction. So that can range from an evaluation or a study. Like right now we're looking for a client to see if they should just build a pumping station for a certain area and convey that wastewater to an existing plant, or if they should build a whole new plant. And that's really cool because it gives us the opportunity to look at all different unit processes of the treatment train and kind of compare and see what would be best for the client. And then obviously like the best part is seeing it built and in operation at the end. That's like really when you get to see all your efforts realized.
Sure. You just used the phrase treatment train. I don't know what that means. I have some ideas in my mind, but could you explain what the treatment train is?
Sure. So basically all wastewater treatment plants have a bunch of unit processes in series that the wastewater goes through. So in the beginning, you'll have screening and grit removal, which is just removing the big stuff that's in there. Then it goes through sometimes a sedimentation, sometimes straight to an activated sludge process, which is just aeration, where bacteria eat up the organic matter or the bad stuff. From there, it goes on to be either further treated for enhanced nutrient removal or just filtered to remove any remaining suspended stuff in the water. And then it gets disinfected and discharged into generally a receiving stream. Around here, we really worry about the Chesapeake Bay, so we try to get our water really clean before it goes back into the bay.
Sure. And are there any other uses for processed waste? I've heard some different things.
Yeah. One thing that Maya didn't mention was that when you come into the wastewater plant, there's almost like two different treatment trains. You have the liquid one, which she just explained, and then you have the solid one. So the solid one, basically all the actual solid waste that comes out from a wastewater plant, whether that's actually in the sewer pipes or developed, actually grown within the treatment facility itself, that we actually employ this bacteria to biodegrade the soluble waste. And so you have these two different solid waste streams. They come together, they go through multiple different processes, thickening, dewatering, stabilization, to basically kill any sort of pathogens in those. And you create what's called biosolids, as we call it in our industry, formerly called sewage sludge. Biosolid sounds a lot better.
Sounds a lot. It's a lot more marketable.
A lot better.
Yeah.
A lot more marketable. That's right. So you actually have. We work with a subconsultant that is called Material Matters, and they actually market this product to be used as fertilizer, whether it's on agricultural fields or if it's processed really well and has really fine product, a really dry product. You can actually use it on golf courses. You can use it for potting soil, soil blending, compost, a lot of different uses for it. We were actually helping a client recently with a new dryer facility we put in, and that we found a landscaper that wants to literally buy all of their material and use that in his fertilizer for his landscaping work. So that's something that doesn't typically happen in our industry because you think of this solid material as waste. And you think it's waste, I have to either send it to a landfill and pay someone to take that. But we're actually, designed a project that's saying, hey, we're now producing a product, a valuable product that someone wants to use and wants to pay for.
That's exciting to see that level of sustainability at a wastewater treatment plant. Like you said, you wouldn't think, you would just think that it's nasty, it's completely useless. We're going to do what we can with it and try to get that water clean again so that we can discharge it. But to actually have a product out of that you can do something with.
And they actually, I guess recently there's been a shift in our industry from, it was formerly sewage plants, then to wastewater treatment plants, and now it's more so resource recovery facility is what people are referring it to. Because not only can you recover the actual organic nutrients that are in, organics and the nutrients that are within the solid waste, but you can actually extract the phosphorus out of the soluble phosphorus that's in the water and then harvest that and then use that for fertilizer as well. So there's a bunch of different ways that people are doing that. And then also one way would be anaerobic digestion, which both Maya and I are very passionate about. In that you basically put all this solid waste, if you don't use that for, say, fertilizer for, for agricultural fields or for golf courses, whatever the end use may be, you put it in a reactor, you keep that at a hot temperature so the bacteria are happy, and they break down that solid waste and produce methane gas. You can then harvest that methane gas either for fueling, say, heating purposes, or actually run it through an engine, generate electricity. We have several clients that do just that. So they're actually able to generate electricity, reduce their power consumption off the grid, and save some operating costs through that. So that's quite a bit more than you probably realized. But,
right. I don't even know what to ask next because there's like 1,000 things I want to know. What, Maya? Can you tell us more about? I want to know more. I need to know more. What else can you add to that? About? I think the sustainability element is really interesting, especially for people that might be looking to get into this industry. I don't know. Tell me something that really excites you about what you do. DJ just mentioned something, but you go for it.
Well, anaerobic digesters are particularly interesting because they are an energy positive process. So in wastewater treatment plants, you use a lot of energy in treating the wastewater. When you're aerating the water treatment train, like I said, that uses a tremendous amount of energy. But the interesting thing about anaerobic digesters is that you have to put some energy into it through pumping and then mixing and heating. But the amount of energy that you get out through the methane gas that DJ mentioned is much more.
Wow.
So it's an energy positive process, which is great. And then I could go into all the configurations of reactors and the way you could optimize that process to best suit that plant or that client. And then just like kind of interesting technologies that have kind of sprung up because now I think a lot of research has been put into how do we get just a little bit more biogas out of it every time to try to optimize it even further.
Right.
Yep. So there's been some like new developments in how to do anaerobic digestion for that.
Interesting. So if we're talking about a typical wastewater treatment plant or
water reclamation facility,
or
resource reclamation facility, resource recovery facility. There's a couple of different acronyms.
Different names.
Yeah.
And so, there's a couple in the Baltimore area, but how many people are typically being served by that facility?
Let's see. I guess in the Baltimore metro area, there are 2 different facilities, and those probably serve maybe over 1 million people between Baltimore County, Baltimore City, small parts of Anne Arundel and in Howard County. But you have, I would say it varies. One of our smaller clients on the Eastern Shore, they might be serving at most 500 to 1,000 people.
Okay.
And you have less than 1 million gallons of wastewater treat there a day. Actually, less than 500,000 gallons, which on our scale, it's typically pretty small. But then you have communities that are anywhere from, say, 20 to 30,000 people, and of those, it might be a couple million gallons of wastewater a day that they're producing. And typically in those kind of environments, Maya mentioned that it's a really energy intensive. You're oftentimes the wastewater facility in a town of that size, 20, 30,000 people. The wastewater facility is going to be actually the highest consumer of electricity in that town, assuming there's not going to be any sort of really large type of manufacturing or industry there. There's typically the most power consumption coming out of those facilities.
That processing takes that much energy.
Yep.
And I guess that's then why the anaerobic digesting stuff is so exciting. Did I say that right?
Yeah.
Yep.
You got it.
You nailed it. Yes. You nailed it, Tim.
Yeah, that makes sense now, why having that positive energy process when you have something that's drawing so much energy. What would happen in one of those facilities if everybody flushed their toilets at once?
They would be just fine.
Yeah, I would say that's actually not that big of an issue, really.
That's it. Okay, all right.
You would say if everyone decided to take a shower at the same time, then you'd have to consider, well, if everyone showered at the same time, then does the water supply system actually have enough water to supply all that demand right there? But as far as rainwater is actually the biggest issue for a wastewater treatment plant. So, and dry, we talk about dry weather conditions, which is just actual wastewater coming from businesses, homes, industries that are actually meant to go into the sewer system.
Right.
And then you have wet weather conditions where you get a lot of infiltration from saturated ground, flows into the sewers. It ends up at the plant, and there's a variety of things that I guess different clients of ours, whether it's equalization basins, saying, all right, I'm getting a huge influx of wastewater right now. I need to divert this around my treatment drain, put it in equalization basin, and then slowly let that go back into treatment. Or sometimes you just kind of have to not necessarily bypass, but you just have to basically hold on and say, all right, I'm going to try to maintain all my processes right now, just get it through, treat it the best I can, and then, get back to normal treatment. It's, I guess there's a wide variety of things that our clients have to do, but rain, especially in the past year or so with, I think it was Baltimore's wettest season
it was
last
a very
year.
wet year.
So wastewater flows of all of our clients were very, very high. It was pretty difficult for a lot of them to actually meet their permits. So those are some of the things that we actually had to help them with, especially with on the biosolid side. Many of them actually do employ, mentioned land application of these residual waste. And so when it's wet on the ground, you actually can't land apply. MDE or whatever state agency like the EPA has limitations as far as when you can land apply the biosolids. And so when it's wet out and with all the rain that we had, there was just stockpiles of all these biosolids at different facilities. So we actually were helping out many clients figure out where can we send this facilities, incinerators, compost facilities, landfills, places that we typically don't necessarily look to for a lot of our clients, but had to kind of think outside the box in that situation there.
Sure. We both are clearly very passionate about wastewater, which is great. And I want to know how you got to be so passionate. What has led you to this point in your career? Maya, you want to go first?
Well, I wasn't always a wastewater engineer. I actually started as just like an environmental scientist. I worked for the EPA for a few years. And that was not for me. It was just not, it was a little administrative. And I was looking for something more technical. I also spent some time in Africa. I did the Peace Corps there. And sanitation was by far like the biggest public health issue that they dealt with there, much more than like malaria or AIDS or other diseases that you hear a lot about. So when I was kind of looking for this career change, my mid-20s, late 20s, I decided that this is where I wanted to go. So I went to grad school for environmental engineering. And then I got a job at a treatment plant, which was the dream. Absolutely.
I love this. This episode is so amazing. I love it.
The dream. And I worked there for a few years, and that was great. And I learned a lot about that treatment plant, specifically on their biosolids processing, everything about those different sludges that DJ mentioned. I knew everything about those and how to treat them and how to process them. But then I wanted to learn a little more about all aspects of wastewater treatment and how other plants do it. And so actually I met DJ there, and when I told him I was kind of looking for a change, he was like, "Oh, I work for RK&K. You should think about it. It's good over here." So here I am.
Here you are.
Here I am.
Mhm.
Nice job, DJ. How about yourself?
Yeah. So I guess when I was first going to college, I was thinking mechanical engineering, nothing to do with wastewater. Never even crossed my mind. I grew up on a septic tank. I never even thought about wastewater treatment. It just wasn't a thing at all that ever crossed my mind. But I got an internship here when I was a junior in college. Was just exposed to wastewater, so it was kind of interesting to me, all the different biological and chemical processes that go into it. And so when I applied to grad schools, I applied both mechanical engineering and environmental engineering. Truth be told, the reason I picked environmental engineering is I got more of a scholarship to go environmental, but I'm glad I made that choice because I ended up really enjoying it. I actually operated small reactors for like 2 years straight throughout grad school, learned a lot. Not probably as much as Maia did, really operating probably multi-million gallon reactors at her facility. But no, I learned a lot about the actual bacteria that we employ to do all these different treatments, whether it's breaking down organics, producing that methane gas, converting nitrogen gas to get it out of the water, absorbing phosphorus to get it out of the water. There's a lot of different biological components that go into it, and it was very interesting to me. And so I ended up, going full time here at RK&K after interning for a couple of years after grad school. And yeah, just kind of, hit the ground running, and here we are between studies, designs, construction. So yeah, no, it's been fun so far.
I want you to think back, both of you, back to the beginning of the career, which we just talked about. What's something that you wish you had known earlier on in your career? Maybe a little snippet of what would be advice for someone listening.
I would say public speaking. At least from what we do, we engage with our clients a lot, and as well as if you give, we go to different conferences, whether it's local and national. We do speak at those on occasion. So you're, talking to your peers, you're talking to potential clients, engineers, professors, and you're speaking to a lot of different people. And I would say that's something that I've developed, I've gotten better at in my career, but it's something I wish I probably would have focused on early on through college, even through high school, things like that, I really didn't think about. As you think engineer, you don't
Right.
think public speaking.
We hear that a lot.
But it's a lot of what we do, and when we have to go in front of clients, explain how we're gonna, how we're actually gonna perform their project, you have to make sure you're, able to do that, and you're not too nervous. A little bit of nerves is good.
Sure.
Want to be sharp, but that's something that I think I would have liked to, kind of go in on a little bit earlier in my career. So
Nice. No, that's good. Yeah, like I said, we hear a lot of people talking about those kinds of unexpected things that they didn't know when getting into engineering and public speaking. That's a good one. Maya, how about you?
Well, personally, I wish I had chosen engineering a little earlier. I guess the advice would be to push yourself technically. I think it's something that I just didn't even consider. I was like, oh, I can't do that. I can't be an engineer. But then when it came down to it, I was kind of like, oh, why not? And so then, I did. And I think that engineering school is tough technically, but I think it's tough for just about everybody. And you work hard and you get through it. So that's good. And just to add on to the public speaking thing, the other part that we do a lot of is writing. And I think that I had no idea how much writing I would do, especially in consulting. And so that is huge. I think my writing has improved a lot just in the 2 years that I've been here, but it was really rusty when I got here because I hadn't probably used it since college and grad school, just writing my thesis, but that was it. So I think focusing on those like things that we think of as English skills or liberal arts or whatever are really important.
It matters, yeah, because you have to sell the project. You have to sell the team doing it. Like, why you have to convince the client, explain to them why you're the best team, the best fit for the project, and you can't do that if you can't write or if you can't speak in front of them about it and explain it to them. Those are both really good pieces of advice. So if you're listening or watching out there, take that one to heart. Both of those. Impromptu poll here for the two of you. Which water is the better water? Wastewater or drinking water?
Wastewater.
Wastewater.
Really?
Definitely wastewater.
Okay. I don't know why I'm not surprised.
Do you want to know why?
Yeah, of course I want to know why. Tell us why, please.
All right. Well, I guess I'll give my short answer in that, there's really nothing to water. It's, you take out some particulate matter, maybe you put in some minerals, whatever it may be. But it's just, water comes in, goes into a couple tanks, settles some solids out, and that's really about it. There's no fluctuation in flows because you're typically, you have a community, they need 8 million gallons a day during the wintertime. The summertime, they use 10 million gallons a day. It's not to talk down to any of our
You're not
water,
talking down
not
to,
talking about any of our water engineers.
Right. Of course not. Of course
but
not.
no,
they can be on for the answer.
They're waiting for you outside the studio right now.
Yeah. But no, it's just there's a lot, so many different facets and unit processes that go into wastewater that are just simply not there on the water side. And so it's kind of, I would say are a lot more wastewater projects out there than water because of that. You have to upgrade facilities because equipment goes down. There's a lot more equipment involved. I would say one of the different things that we do, not just our wastewater treatment, but as well as our municipal engineers and even water, is that we use a lot of equipment, a lot of pumps, blowers, screening equipment, valves, piping that not a lot of the transportation people even realize. We design systems that have power controls and things that actually need to be, actuated at the right time, open, close, all these different things that that go into actually designing these processes. It's pretty intricate and it's challenging at times, but that's kind of the fun of it, is actually problem solving, figuring out ways of how you going to fit this in this confined space, and then how are you actually going to make it work and operate so that's user friendly. So those are kind of the challenges that we go through, and I think it's just kind of getting off task here, but there's a lot more of that in wastewater than there is in water. So I mentioned at the beginning that'd be a short answer, but that was quite a long answer. So, there we are.
I have to say, I've always, the couple of facilities that I've been lucky enough to go out to.
Lucky enough, huh? Yeah. You
let
that 6 a.m. flyover.
The 6 a.m. to the sunrise drone flight. That produced a really nice video. Thank you for coming out there with us. But those are massive facilities, like, at least from my perspective, like, because you think of wastewater treatment, like you said, it's much more complex. I think of it, you flush your toilet, it goes to the place, it goes to a screen, whatever, it's done, right? But no, how many acres was that facility on? Do you have an? It's huge.
It's I would say it's a couple hundred, but I don't know how many.
That's okay. Yeah. You have to know exactly. But the point is, it's big. Like, it take you a few minutes to drive from one end of it to the other. And these are large places, and just because of all that equipment and all that piping that you mentioned. Maia, do you have a complimentary answer to why wastewater is better?
I agree with what DJ said. I think ultimately it's just more complicated, and so that's why it's more interesting, because wastewater is just more challenging. There can be stuff in it that comes in. It can have pathogens, corrosive gases. You kind of it's just a more complicated substance than pulling water from, say, a river. And so there's more things that you have to do to treat it to get it clean. Now, I don't want to disparage drinking water too much. Like, I enjoy it. I drink it every day. I'm happy to have
drinking
it.
some right now.
Yeah. So it's very important. I just think it's more interesting to design wastewater treatment facilities than water treatment.
Fair enough. To all the water engineers out there, no, we'll have one of you on the episode soon, and you can defend yourselves. What's something that we haven't talked about yet that the two of you would like to talk about?
I would say one thing I was thinking about as we were kind of going over this and all the different complex systems that we have to deal with is, I would say Maia and I are lucky in the fact that where we are is the Chesapeake Bay region, and that we deal with some of the most stringent limits as far as organics, nutrients, specifically nitrogen and phosphorus. So we're kind of always on not necessarily the cutting edge of technologies of treatment trains, but as far as Maryland's concerned, it has like some of the most stringent limits. So that means that the systems that we're employing here compared to the rest of the country are pretty technologically advanced. And they are some of the probably best treatment systems in the United States. There's places, Florida has pretty low limits. Much of, obviously, I mentioned the Chesapeake Bay, so Virginia as well. Some places, out in the Midwest. But for the most part, Chesapeake Bay region is really, really tight. And so it's there's a lot of different projects that go into making sure we were able to meet those limits. And it's kind of been a wide variety of projects that we're able to get our hands on. So that's something that's been pretty cool and been fortunate enough, I'd say, to be in this region.
And that's all because of the bay.
Yep.
And it's the sensitivity of it and protecting
Yeah,
it.
it's trying to limit the nutrients that go into the bay. So as you probably know, it's they have issues with eutrophication or dead zones in the bay. And so MDE or EPA have really regulated the amount of nutrients that all point sources, which wastewater treatment plants are, can put into the bay. And so that's like regulated on a pound per day basis. So basically that means you have to go down to a really low concentration. And as DJ said, that keeps us pretty much on the cutting edge of technology for specifically nutrient removal. And so now it's interesting because to limit the nutrients going into the bay, you have to look at other sources like stormwater, runoff, farms, things like that. And so I feel like on the wastewater side, we've done a lot, but there's other contributors that also need to work on treating their runoff or the water that goes into the bay to continue the improvement of the bay's health.
Sure. But it's exciting to be sort of at the forefront of doing well in that area, of the nutrients that you're putting into the bay. That's pretty cool.
Mm-hmm. Yeah. There was actually, I think it was 2004 is when I believe it's Maryland implemented what's called the Chesapeake Bay Flush Fee. And so at that point, they started taxing everyone in Maryland, whether you had sewer system or not. So if you flushed and it went to a wastewater treatment facility, you paid X amount. I think it was like $25 a year, and that was just tacked onto your sewer bill each month. But if you didn't, it would go onto your property taxes, even if you're on a septic system. And that whole idea, because if you have a septic system, you have water that's flowing out of your septic system, it's going into the ground, eventually getting into the bay still. So that's why, just because you weren't on an actual sewer treatment facility, you still had to pay that.
Contributing.
Yep. Yeah. And so that funded a lot of different projects through the mid to early 2010s. And so that's why a lot of projects were able to happen and have in the past probably 15 years. So
sounds like a good use of the tax dollars there.
Mm-hmm.
Yeah. All right. We've arrived at that point in the show where you're each going to give us your pick of the week. Dun 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 dun. I should have had music queued up for that. I need a little ditty. Maia.
Yes.
Your pick of the week is what?
My pick of the week is Suspended Brewing. It's a little brewery in Pigtown. It's right by my house, so that makes it really convenient to me, right on Washington Boulevard. It's a little brewery that was started about a year and a half ago, I think, by UMBC grads. And it's real nice. It used to be a theater. They have these big chandeliers still. They have the old marquee up. everything they brew there, they serve there in their tap room. Super family friendly. There's always people with dogs and kids running around, and it's just like a nice atmosphere. You can bring food in if you want. They also have pop-ups there. They had Ekiben last night. They have other stuff. So it's just like a nice place to hang out. They're open on the weekends, I think Thursday through Sunday.
Nice.
Suspended Brewing.
Suspended Brewing. Okay. DJ?
It's a Ravens tailgates.
Ravens tailgates. Okay.
Yeah.
and,
So
I mean, the Ravens are
Ravens right now are
best team in football.
Best team in football, 12-2. Gonna take care of the Browns this week. But no, tailgates. I live a stone's throw away from Raven Stadium, so I would say I'm at almost every tailgate, whether I go to the game or not. Always fun as far as just everyone's excited, especially this season with how good we've been, and got Lamar leading us all the way right now. And yeah, so I would say Ravens tailgates.
Tailgates are a good time. Yep. All right. Well, good. Well, hey, thanks to both of you for coming by. This has been a lot of fun. I've learned a lot. Treatment trains, anaerobic digesters, and why wastewater is better than drinking water. So that's a solid episode. Thank you all for joining us for another episode of Inside Engineering. We release a new one every Tuesday. So be sure to subscribe. You can check us out at our home at rkk.com/podcast, where you can watch or listen or subscribe on any of the channels that we're on. Also, we have a short anonymous survey there. You can rate this episode and tell us how we're doing. We love your feedback, so we appreciate that. DJ, thanks for stopping by.
Thank you.
Maia, thanks for being here.
Thanks, Tim.
We'll see you all on another episode of Inside Engineering.